Have you ever wondered how, when you search for a product online or look up a friend on social media, the results pop up instantly? Well, there's this incredible, invisible piece of tech making it all happen. Today, we're going to pull back the curtain on that secret, the database index. Okay, just think about this for a second. You've got a massive 500-page textbook, and you need to find just one specific topic. Without an index, without a table of contents, what do? You're stuck flipping through every single page. It's slow, it's frustrating, it's a total nightmare. Well, that's the exact problem a database faces when it has millions or even billions of rows of data.
So the solution to that digital page flipping problem? It's the database index. And at its core, an index is really just a special kind of cheat sheet. Instead of the database having to read every single row to find what you're looking for, it just checks the index, which points it exactly where it needs to go.
Let's really stick with that book analogy, because honestly, it's the perfect way to understand how this whole thing works.
Think about it. The process is something we all know. You want to find this section on artificial intelligence. You're not going to start reading from page 1, no way. You flip to the back, you find the term in that nice alphabetized list, and bam, it tells you the exact page to go to. A database index does precisely the same thing. It's a sorted list that has pointers telling the database exactly where to find the data you asked for.
All right, so we get the basic idea. It's a shortcut. But how does a database actually build and use this shortcut? Let's take a quick peek behind the technical curtain.
You know, the magic here is all about organization. Indexes use these super efficient data structures that are built for one thing and one thing only, looking stuff up fast. The most common ones you'll hear about are B-trees, which kind of work like a branching decision tree to narrow down the search, and hash tables, which are amazing for finding exact matches. Both of them let the database find what it needs incredibly quickly.
And putting this into action is actually pretty straightforward for a developer. They just use a simple line of code like this one. This is basically a direct order to the database. It says, hey, listen up. People are going to be searching the users table by name all the time. So go ahead and build one of those super fast shortcuts for that name column.
And the result of that one little command is, well, it's a massive performance boost. Before, if you wanted to find a user named Alice, the database might have had to scan millions of rows. But now, it just glances at its new index, finds Alice in a few simple steps, and pulls up her data almost instantly.
But, and you knew there was a but coming, right? In engineering, this kind of incredible speed boost doesn't just come for free. There's always a trade-off.
So here's the deal. On the one hand, the benefits are awesome. Your reads, your searches become lightning fast. But on the other hand, there are a couple of downsides. First, the index itself takes up extra storage space. And more importantly, every time you write data, like adding a new user or updating a name, the database has to do double the work. It has to write the data to the main table, and it has to update the index. That makes writing data just a little bit slower.
And that brings us to this really key piece of wisdom. You don't just slap indexes on every single column. You have to be strategic about it. They are absolutely perfect for what we call read-heavy systems. Think of a product catalog or a blog where you're searching for information way more often than you're adding new stuff.
Okay, let's pull this out of the abstract world of databases and into an example that you probably deal with every single day. Think about the last time you were shopping on a big online store. You type what you're looking for into that search bar, you hit enter, and you expect results right now.
That instant result, that's the power of an index. If that website didn't have an index on, say, its product names or categories, every single search would force the database to scan its entire inventory. The site would be so painfully slow that you'd just give up and go somewhere else. And we're talking about a mind-boggling scale here, often millions and millions of products. Trying to scan that entire list for every single user every time they search for something, it's just not possible. Indexes are really the only thing that make our modern online shopping experience work at all. So look, if you take away just one thing today, let it be this. A database index is the ultimate shortcut. It's the digital version of a book's index, and it's the thing that makes finding that one needle in a gigantic haystack of data not just possible, but lightning fast.
Which leaves us with a really interesting final thought. If an index is the shortcut, well, that kind of implies there are different roads you can build, right? What are the different types of indexes? And when would you pick one over the other? We'll dig into that next time. Thanks for joining me.